Should you use electrical tape when you install a new outlet or a new light switch or not? That's probably not the only question you've had when it comes to DIY electrical work that's resulted in conflicting information. So in this video, we're going to take a look at the myths and the best practices related to home electrical work, so that way you can tackle your next project with confidence. When you're installing a new receptacle or a new light switch, do you go back and wrap it and cover the terminal screws up with electrical tape after you made your connections, or do you leave it bare? Now, the argument is that if you leave it bare, you're going to have a higher risk of this arcing or shorting out inside of the box because of maybe a loose wire or some wire loosening up over time, or if you have multiple receptacles or multiple lights in a box and the box is really tight, you're going to risk something coming into contact with those terminal screws that you don't want to come into contact, potentially arcing and starting a fire. If you wrap the terminal screws with electrical tape after you're done, it adds another layer of protection against that risk. If you're installing receptacles in a box and it's just a single receptacle, then you don't necessarily have to wrap it in electrical tape, especially if the terminal screws are tightened down all the way. However, you can if you want to. But if you're installing a lot of receptacles in a single box or multiple light switches in a box, best practice is to always make sure your terminal screws are tightened down and to wrap the terminal screws with electrical tape to provide a little bit extra protection. There's a lot of confusion and debate around which way to install a receptacle. So one way is to install it with the two polarized prongs at the top, and the other way is to install it this way with the ground prong at the top. Now, typically you'll find in homes and residences that the two polarized prongs are at the top, and in general, you'll find that in commercial applications, in like office buildings and things like that, you'll find that the ground prong is at the top. Now, the reason for the ground prong being at the top, just in general, is the argument is that sometimes these devices that are plugged into this, sometimes plugs that are plugged in, have a tendency to try and work their way out. And then you'll have the two metal exposed prongs that could potentially short out if a metal object happens to hit across that. Well, if you have this installed to where the ground prong is on top, it's going to be less likely for a metal object to fall into this and cause a short between the hot and the neutral terminals and, potentially start a fire. Now, that all makes sense. As you can see here, this is hanging out partially, and it would be really hard for the metal object to come into contact with both the neutral and the hot sides. However, the argument really doesn't hold up when it comes to devices that don't have this ground prong. So even if you have your receptacles installed this way, where the ground is on top, if you're plugging things into it that don't have this ground prong, it's really not going to provide you any additional protection. So because of that, typically I recommend you install these receptacles with the two polarized prongs at the top, with the exception being if this is a switched outlet. So sometimes you'll have an outlet in a room that's controlled by a wall switch, and if that's the case, you'll want to install this upside down. So this is just a really easy way to tell in a room if there is a wall outlet or receptacle that's controlled by a wall switch, say for a floor lamp, for example. And this is pretty common with older homes that don't have lights in the ceilings. So if you ever walk into a room where you see all the receptacles installed this way, except for one, then that probably means they didn't make a mistake. It's just controlled by a switch on the wall. One question that comes up a lot is whether or not you can mix different wire gauges on the same circuit. So for example, I've got some 12-2 gauge wire here and I've got some 14-2 gauge wire. So the one thing you absolutely cannot do is install wiring on a circuit that is rated for a lower amperage than what your circuit breaker is. So for example, if you have a 20 amp circuit breaker, you have to use 12-2 gauge wire or larger in order to be able to handle that much current or that much amperage that's coming through that circuit. So you'll want to use 12-2 wire here. And if you're wanting to extend that circuit, say adding another receptacle or adding a light switch, you cannot do that with a 14-2 wire, which is only rated for 15 amps. If you do that, you risk this melting in the wall if it draws too much power, and you could potentially burn down a house or building or whatever it is that you're wiring up. Now you can, however, do the opposite. If you have a 15 amp circuit and you're trying to extend that, and you want to use 12-2 wire, if you're wanting to use wire that's rated for 20 amps, that's not going to pose any fire hazard risk. So you can always use a larger gauge wire, but you can never go smaller than what the circuit breaker is rated for. One very debated practice is whether or not you should use the side screw terminals to make your wire connections, or whether or not you should backstab that device when you're making your wire connections. Now, the argument can go both ways. If you're looking for speed, then you can use the backstab method, which is basically just pushing the wire into a hole in the back of either a light switch or a receptacle in order to make your wire connection into that device. The traditional method and traditional way of wiring this up would be instead to use the side screw terminals create a J-hook with your wire and then screw this down and tighten it down to make your connection. I see a lot of professionals using the backstab method, and I see a lot of professionals using the J-hook method. So which one's better? Well, I would argue that the J-hook method is the best practice here because this is going to be less likely to loosen up over time. Whereas with the backstab method, this is just being held in place by a little clip inside of this. So these can and do loosen up over time, especially if you have a light switch or a receptacle that's loose in the box and it tends to move back and forth. This connection can loosen up and it can cause you problems down the road. So I highly recommend using a traditional side screw terminal to make your wiring connections. And the exception to that is if you have a spec grade or commercial grade receptacle that has a back wire method of installation versus a back stab method. And let me show you the difference between the two. So here, as you can see, the back stab method is basically just this wire being pushed and held in place in the back of this light switch. And it's just, like I said, a little clip that's holding this in here. Versus on a spec grade, you can see the difference here is you can put the wire in the back channel of this, and then the way it makes its connection is it's not held in place by a little clip. It actually uses the screw terminal to tighten down this clamp that's in the back and make the connection solid. So my advice, if you're going for speed and quality, is to get a professional or spec grade receptacle or light switch and use the back wire method instead of the back stab method. Should you use a non-contact voltage detector, or should these things be avoided at all costs? Now, you'll hear a lot of debate back and forth as to whether or not these should be used. And the argument against them is that they're not as reliable as other methods are. So like, for example, if you're working on an electrical receptacle, it's best to use something that plugs in to check to see if the power is turned off. However, I would argue that you should still have one of these because it does give you an additional layer, a level of peace of mind that you can check things that you can't with a plug-in detector. So for example, if you're working on an older home or if you're working on a home that's been remodeled, it's pretty common to find electrical boxes that have multiple circuits. Not really a way to check the light switch other than flipping the switch on and off, which may or may not work depending on if you have a bulb installed. So just having one of these helps to give you peace of mind that all the power is off in a box before you start working on it. And if you happen to find something that's live in a box when you thought the power was off, then it kind of convinces you that these are definitely great to have on hand, and these have definitely saved me before. So I highly recommend having and using these in addition to other methods. Wire nuts versus WAGO lever nuts, which is the best choice when connecting wires to each other. So obviously the wire nut is going to be the traditional method if you're having to do something like install a light, or if you're needing to create a pigtail for a connection in the wall when you're installing multiple receptacles, then your wire nut is the tried and true solution for that job. Now, there are some limitations with wire nuts, however. For example, if you're redoing a connection, it's best to replace these versus reuse them. And if you're having to connect solid wire to stranded wire, these always don't provide the best connection. So in those cases, it would be best to use a WAGO lever nut. So with WAGO lever nuts, you can insert and remove wires by just raising and lowering the lever. So for example, if you're having to install a light that has stranded wire, a WAGO lever nut is a great way to connect the stranded wire with the solid wire and make your final connection. WAGO lever nuts are also a lot more convenient too, because you don't have to make sure the wires are twisted together and that the wire nut is seated correctly. These are really easy to just open up the levers, put in the wires, and close them down, and you know that the connection is solid. Now, there's going to be arguments against lever nuts that maybe they're not as good as traditional wire nuts. They don't hold the connections as well. They're not rated for as high of amperage, et cetera, et cetera, et cetera. But generally, those things are not true. The only thing that is true or that can be true is that if you're putting a lot of electrical connections into a single box, these levers do have a tendency to want to pull up depending on how much is in the box and how much you force everything back into that box. These can open up and can cause your connection to be loose. So what I would recommend in those cases, if you have a really tight box, is to just wrap this with electrical tape to keep those levers down so where they won't open back up, and you should be good to go. Otherwise, the arguments about these not being able to handle as much amperage or not being as good as a traditional wire nut just don't hold up. In my opinion, these things are great. They are more expensive than a wire nut, but if you're doing a lot of light electrical work around the house, like installing new light fixtures, for example, these are great, way more convenient to use than a traditional wire nut, and I always have a bunch of these on hand. For older homes that are wired without a ground wire, it's always a struggle and a challenge to figure out how to plug in something that has 3 prongs, including the ground prong, into those outlets. Now you have a couple different options. Typically, you can use a cheater plug, which basically takes a 3-prong input and only gives you the 2 prongs or the polarized plugs on the output. So that way you can plug it into a receptacle that doesn't have a ground on it. Now these can work in a pinch, but I really don't like to recommend these, especially if you're having to plug in something like an appliance to the wall. The reason I don't like these, I don't recommend these for appliances specifically, is that appliances tend to have metal casings on the outside. And if those devices, if those appliances happen to have a short inside of it, or if they're designed to leverage the ground and you happen to touch that metal casing, then you might get shocked or you might get electrocuted because it's not wired the way it was designed. So in order to avoid that situation, in order to make sure you have another layer of protection, I highly recommend, if you cannot rewire your home, to instead replace your 2-prong receptacles with GFCIs. And the reason for that is because a GFCI is going to add an additional layer of safety and protection onto your circuit. So if you happen to have any kind of an issue with a ground fault, this is going to be able to protect against that without having to have a ground wire installed. And the way it can do that is because there's circuitry that's built inside of this that monitors the amount of current flowing between the hot and the neutral terminals on a outlet. And if it detects any kind of an anomaly, if it detects any kind of a variance between those two, it's going to shut off the power to this receptacle by itself, and it again doesn't have to have the ground in order to operate. Now these will not provide a true ground, so if you have sensitive electronics or something like that that requires a true ground, this is not going to cut it for you. Unfortunately, you're going to have to install a ground wire. But if you're just wanting to make sure you're being as safe as possible, these are a great option and a great alternative to having to rewire your house. If you found this video helpful, please hit the like button. It really does help out the channel. And also check out this other video next. I'm sure you'll like it too. All right, thanks for watching. I'll see you in the next one.